Okay, here we go. Oh, by the way, congratulations, volleyball. You guys beat Mankato West, huh? They were 18-1. That's got to feel good. And soccer won? Wow. Everybody's on a roll. I didn't win. Swimming? Swimming won? Very good. Preston, how's our boys soccer team doing? Congratulations. Who'd you beat? East? Score a goal? You're kind of a defense guy. Yeah, you're too big and muscular to play up front and score goals. So many times I leave Preston speechless. All right. So absolute values. Here's what we got to do. Okay. Absolute value of x is equal to 5. You tell me the two solutions. So what that tells us is the way that you remove an absolute value sign, the way that you remove it is you set up two equalities. One that's positive, one that's negative. We're going to do the same today, but we're going to focus on inequalities. Equalities is easy. You guys have done that before. And we start by this. Let's say you have an absolute value of an expression that's less than a constant. Did you learn this last year, that if you see less than, you can think of it as less than, and it's a conjunction? Does that look familiar? And if you see greater than, it's great or. And that's a disjunction. Let's try an example instead of going through the rest of that so you guys see exactly what I'm talking about. If you see an absolute value, it says solve and graph the following inequalities, represent the solution set in interval notation. 2x minus 3 minus 9 is greater than 21. How do you think we start by solving that? We add the 9 and set it greater than 30. So when you see an absolute value and a constant, if you see great or than, you know it's going to be a disjunction. The arrows are going to go to opposite sides. The way that we get rid of the absolute value signs, hello! How are you? Great, never better. Just thinking of one person I want to see walk through that door and, yep. I set up two inequalities when I take off the absolute value signs. One that's positive, one that's negative. The negative one we have to flip the sign for. Okay? So two of them. The first one's exactly like the first one that's set up. The second one is different in the sign of the 30. It changes to negative, and the inequality sign flips as well. So I just solved these independently of each other. 2x is greater than 33. Divide both sides by 2. X is greater than 16.5. The other one, if we add 3, we get 2x is less than negative 27. Divide by 2. X is less than negative 13.5. So we want to do two things. We want to graph the solution set, and we want to express it in interval notation. So I plot negative 13.5, and I plot 16.5. Open or close circles? Open. 16.5, x is greater than that, so arrow goes to the right. X is less than negative 13.5, so arrow goes to the left. So is that a conjunction or a disjunction? It is a disjunction. Do you see that I knew right away it was going to be a disjunction? Because it says the absolute value is great or then. Great or. Great. No. Full play on words. No. Alexis says stop it. All right. All right, if I'm going to express this in interval notation, I have negative infinity to negative 13.5. Unioned with 16.5 to infinity. Yes? You've solved these before, right? Piece of cake, upside down. You can do it. The next one I solved the same way. Absolute value of 3 minus x is going to be less than or equal to 5. So can somebody tell me, is this going to be a conjunction or a disjunction? Conjunction, because I see a less than, and means conjunction, together. So I can take off the absolute value signs. The only way I can take off absolute value signs is if I set up two inequalities. So I set up my 2. I switch the sign on the second one. One positive, one negative. Switch the sign on the negative. Now I solve. Negative x less than or equal to 2. When I divide by negative 1, I have to. So x greater than or equal to negative 2. Same thing here. Negative x greater than or equal to negative 8. Divide by negative 1. I switch the sign. Less than or equal to positive 8. I will graph the solution set. Open or close circles. And you can see from the beginning we knew it was going to be a conjunction. It does in fact go together. As you represent the solution in interval notation, we have negative 2, we have positive 8, done and done. What do you think? You remember this? All the problems I have you practice today, I have you practicing 8 problems, and they're all just basically just like this. But quick, I want to talk about some special exceptions. So think about this. There's no work to really show here. You just got to think about it. True or false? An absolute value is always positive. Technically, it could also be 0. But is an absolute value always greater than a negative? Yes. So your solution set would be from negative infinity to positive infinity. So if you ever see an absolute value set greater than a negative, you know that that's true for all numbers. You don't even have to solve the equations. You just know it's going to be true. If you saw the absolute value of x plus 2 is greater than negative 49, I don't care what number you give me, any number you give me for x is going to work out for that scenario. You don't need to go through solving it. You might just confuse yourself in that process. All numbers work. Can an absolute value ever be less than a negative? True or false? If I'm a number less than 0, I am negative. True. So can an absolute value be less than 0? Never. What if we had the equal sign? It can't be less than 0, but could it be equal to 0? In that case, there is one solution. And you just set it equal to 0 and solve it. Are all absolute values greater than 0? Unless they are equal to 0, right? Let me show you an example. What if I had the absolute value of x minus 3 is greater than 0? I set up 2 inequalities. My first one, x minus 3 greater than 0. My second one, x minus 3 less than 0. The sign doesn't change on a 0, does it? So when you solve this, you get x greater than 3 and x less than 3. If this is all numbers greater than 3 and all numbers less than 3, what's the only number that excludes? 3. If you draw this graph, look at what happens. You get 3, you got numbers greater than 3, you got numbers less than 3. The only one that doesn't work is 3. So for this kind of solution, if you get absolute value of x greater than 0, you would have just the exclusion of one number. And if you get greater than or equal to 0, again, that's going to be all numbers. Because then you would, if it could be equal to, that would fill the dot, and you would have all real numbers. So let's look at a couple basic special case scenarios. These will go super quick. 6 times the absolute value of x minus 5 is less than or equal to 0. I divide by 6. Absolute value of x minus 5 is less than or equal to 0. So there's a special case. The absolute value of something is less than or equal to 0. Can it be less than 0? No. Could it be equal to 0? So I just have one solution. Take this, set it equal to 0, and solve. Done. If you have just one answer, technically you list it in set notation. I don't care if you do that or not. If you wrote x is 5, that's fine by me. If I subtract 18, 2x minus 3 is greater than negative 8, is an absolute value going to be greater than a negative? Is it always greater than a negative? Is there any time where an absolute value is not bigger than a negative? Oh, it got cut off when I printed the notes. I don't know how. I'm sorry about that. I forgot to mention that I did that in the other class. I just threw the 10 there. That somehow got off of your notes. I don't know how. I don't remember. Sorry about that. So I made up the number that I knew I wanted to work out in the scenario. So if I subtract the 18, again, is an absolute value ever not greater than a negative? It's always greater than negative. This is always positive, and a positive is always greater than a negative. So this is going to work for all real numbers. So I don't have to go through the process of solving if I see a scenario like that. So here's the idea. If you see a negative or if you see a 0 across from the absolute value, you know you might have to think about it. Now I don't give you any examples like that today, but I just wanted to further your understanding a little bit. All I want you to do, you have the rest of the hour to work, is to just work on these 8 problems. Page 87, numbers 59 through 66. That's it. What's that? Yes. On your homework. Or something else. Not something for YouTube Nation to hear. Okay. Should we... Oh, 4th hour figured it out. Did I tell you that? Yeah, it was Claire Ellis. Claire Ellis figured it out. She was gone yesterday. She watched a YouTube video and she said, hey, you've been really mean to 4th hour. I want my candy bar now. So that's how it worked. So I would do the same thing for 5th hour, but it wouldn't be much of a surprise, would it? It would not. Oh, okay. I'll just bring you all candy someday.